Welcome, everyone. Thanks so much for joining us today. I'm really excited to be walking through some of the latest and greatest features in the LandingLens platform with a data set that you can actually follow along with. Let me just skip through my next slide here. Our goal today really is to allow you to have some hands-on experience with the platform itself and learn some best practices, look at how you're working with your data overall to really drive project acceleration. And then hopefully, a little connecting and networking right at the end with the Q&A component. But hello, everyone. I'm Erica Gilbert. I am a customer success engineer at Landing AI. I have been here over a year at this point, and I'm based in the Boston area. So welcome, welcome. And while we get into it, I'm going to go ahead and just disable my video so we can focus on the task at hand. But we'll do a brief overview of Landing AI and LandingLens, but then primarily we'll be focused on the walkthrough with a specific subsea inspection application today. And then we'll wrap up and do that question and connect. So just briefly, our goal really is to help companies build, deploy, and scale visual AI solutions. And we do that primarily, though with other very compelling technology like our LVMs, we do that primarily through LandingLens. And this is our end-to-end platform that really accelerates the process. Though it's made to be easy to use, and it's a very complex and comprehensive platform that serves a wide range of different industries, such as the semiconductor space or the automotive space. But we're seeing increasing adoption in areas like agriculture and medical imaging. And then, of course, the application we're going to focus on today, which is with infrastructure inspection. At a high level, the platform itself offers key capabilities around data management, model training, and deployment. So it really is meant to get you from all of the components that come with data management, like having labeling books, being able to see agreement in labeling across your subject matter experts, and build an audit history with data snapshots as well. And you'll see that with some updates in the platform as we go through the walkthrough today, while also being super deep and comprehensive in what we provide for model training, both allowing for customization and configuration, but also the ability to have a one-click approach where you hit the easy button on your complex model training operations. And then ultimately deploy, which you'll also see in the walkthrough today. So beginning to end, we have roughly an hour today. You'll see a model developed and deployed, so you can just see how rapid that acceleration to your visual application can ultimately be. Today, the application at hand is performing subsea inspections. So you can imagine with the video going along the ocean floor, there's miles of that video to review. And leveraging visual AI, these inspections become much more efficient, safer, and reliable, and help that operator go through that cumbersome set of video where the details are actually very hard to see and ultimately very easy to miss. This is a complex application that working with visual AI really assists the human operator and helps to improve overall accuracy. Some of the things that you'll see as I'm going through the platform, I wanted to just highlight at the forefront around best practice. These are sort of tips and tricks in the LandingLens platform, is to label the inverse order as you're going through that initial process so that you don't have to reselect the class label. It's just a small little option that allows you to save time. Key and bigger best practice for data annotation components here are to really review the images collectively as you're going through the labeling. It's very easy to sort of toggle back through, especially in this use case where we're looking at video. So these are frames of a video. So you can imagine image to image, they can be pretty consistent. So just making sure that your labeling strategy is consistent and having that aggregate and then back and forth view is really helpful to sanity check before you actually train a model. And then for this particular application, because you always want to label classes that are visually consistent, it would actually be ideal to label all of the plant life that is in the video. And so you'll actually see some predictions of other plant life that are not close to where we labeled, and that is because they are visually similar. But in this case, we labeled just the plants close to the pipeline, just to accelerate my own preparation for the workshop and then for your time here today. Segmentation labels, we're going to see both object detection and segmentation can be quite time consuming. So I'll show you some capabilities that help accelerate that as well. And then from a model perspective, it's very helpful to label and train iteratively. Depending on the size of your data set, you might adjust this number, but for our application based on the data that I used, I did that every 10 images, and it helps you to get an understanding of where the model is predicting, where there's overlap in your ground truth, the label you provided, that can help refine your label strategy going forward. And it's really important to always use a test set. There are some options to sometimes just split your data for the model learning process into just a train and development split, but that can be misleading in how ultimately the model might perform in a real world scenario. And then looking at this application in the real world, it's likely, though we've done segmentation because the pixel level precision is very helpful when you have large objects such as this for bounding boxes, it's likely that in a real life scenario, you would take those segmentation masks and use post-processing to convert them to bounding boxes, because that would be sort of easier for the human to see as they're looking at that video. And then in addition, the best practice would ultimately be to label all plants, but you could apply post-processing, and I'll show how you can configure that in LandingEdge to only show those predictions when there is overlap with the prediction of the pipeline today. So we'll be labeling both for pipeline and then see plants close to that pipeline. And now we'll actually do the hands-on walkthrough of the platform. I just wanted to highlight again what we'll be going through. So we'll be looking at the data annotation tools, the model training and best practices around that, looking at the predictions, the model reports, the ability to review across your different model trainings, again, recommending that iterative approach, and then troubleshooting for inaccurate predictions. And the goal at the end here is to get this deployed. So how can we do that rapidly with a streamlined deployment process? So I'm going to hop over to the platform. So as you're familiar, if this is your first time looking at LandingLens, you'll see your recently accessed projects here right on login. Otherwise, you can tab over to see all of your various projects and search across based on the type and potentially the name and creator, but also be vigilant in labeling your projects themselves. When you create a project, it gives it just an inherent name of new project, and you have to click in to edit that. Making it consistent and searchable with your descriptions is very helpful over time. So where we're going to start is actually in the segmentation project that I've developed here. You can see that we have a set of 50 images with some of those actually labeled, 40 of them, and 10 of them remaining. And that we have done a good job of splitting up our data with train, dev, and test. The platform helps auto assign those components. So quick view of being able to see they're actually equal numbers of labels with pipeline and these close C plants here. And I can always bring in more data if I would like. And it's important, just dependent on your use case, to tag tag, and this can be any custom tag that you provide. If you add this in, you'll be able to filter on it within the platform. So if there are any key components or specific metadata features, you can create that on upload. So again, that goal just really being around how you may be looking to find that data later. So you can see I've created a tag here for a set of data that I'd like to test consistently as I develop and iterate on this model over time. And that is the golden test set. So I'll show you how to leverage that when you're doing your model comparison in just a short little bit here. We can see on the overview page here that we have sort of a set of lighter color predictions. So that lighter color versus this darker purple and yellow is sort of the contrast view of what predicted versus ground truth labeled is in the platform. And what you can also do is adjust based on the models that are available and the confidence threshold to see more or less. So the initial model with less data, you can see the predictions there, even with a very high confidence, are smaller in shape. But we can reduce that confidence threshold potentially to see more prediction there. And then you can see based on the ground truth I provided for those labeled images, what ultimately that looks like in an aggregate view as well. But let's actually work with the latest model here and come into some of our data as it's unlabeled. So we can choose to select for that here, or we could navigate and click on it directly. So again, I see those sort of fainter predictions directly on the image. And now clicking in, I'm brought up into the labeling and data annotation interface. And I can see a lot of information about the image, sort of the sizing here, unique IDs, the original title of the image itself. And I can also choose potentially maybe I'm working with teams and I want to add a tag that maybe this needs review. I want to just consult on other team members, and we could go back together and review ultimately that way. Or I could actually add this to the label book as well and create some consistency around how the team is working together. But here I'm seeing the prediction view, and I get some mass overview here to visually see what ultimately that is. So obviously I've done multiple trainings on this model yet, but I'm at the point where I actually want to label. So I need to select a tool for which I want to label. And once I do that, those predictions do move off of the screen so I can focus on the task at hand. I always recommend when you're starting projects to leverage our smart labeling tool. You never know ultimately how much faster this could be based on that. So in this case, we see the tool itself is aware of the different textures and lines and colors within the image, in addition to having some broad understanding of different various types of objects. So this is leveraging some of the segment anything technology that is available. So you can see I've selected my class already here. I have that segment anything tool. And now I'm able to just save for the label here if I would like, and hit return. Or I could actually come in and now refine and add to this if I would like, but actually it looked pretty good going forward. And then select for my other class here. So we do have a plant here, and it's great to always adjust. A lot of concern is often given to when there's these graphics as an overlay. Because it's a video, they sort of move across objects. And with enough labels, the model will sort of understand what you're actually focused on. And I haven't seen an example where the model is learning ultimately the compass as the sea plant, because again, there's pixel distinction across those two different components within the image itself. Control Z is often one of my favorite quick shortcuts in the platform, just to undo any last action. In this case, I don't ultimately want to do that, so that's great. But then it's also very helpful to come in and refine edges of what you're working with by using the minus here. And now I can come back in and adjust. You can see it sort of connects the dots when there is overlap. So again, you can move through this process pretty rapidly, especially depending upon how well the smart labeling capability is available. And of course, it's also very helpful to zoom. And there's the ability to zoom in with just the equal sign here. You can see there, it's very blurry and a lot of one color. So getting close and being very precise in your labels will ultimately help how your model performs going forward. I'm going to label just a couple more images here with our tool. Yeah, I didn't see the plants would come up, but I just wanted to test again. And for the purposes of demonstration, I will not be as precise in my labeling. And then you can see how you might access the labeling book, and if there's any detail about how the labeler should be working with the sea plant right there. And I'm going to reselect for my brush tool, go to my next image, and you can see here I'm not reselecting the class from the previous image. Helps me move a little bit faster. And sometimes I just find that it's here instead of using the segment anything to do this myself. Oh, I forgot to hit plus there. And we'll just add one more. This is just for the purposes of, so we can see the model training capabilities. But in real life, you would want to be as precise as you can. And again, consistent as possible. All right, so these auto save, so that's great. And I get a little signal, so I don't have to press any additional buttons to do that. So I can see now I only have a few remaining that are unlabeled. And I have two options for training. So I can hit the fast and easy button. So this will take and assemble and organize the data. Or I can select to do a custom training. You can see we're auto assigning the train, dev, and test splits for our particular model. And we can select on how we want to assign that for classes. So maybe if I had more unequal distribution of my labels, I might select that differently, but I could also adjust if potentially I wanted to increase, especially dependent upon how much data I have, what that percentage split is. But this is typically the best practice of 70, 20, 10. And you can preview, of course, the different class and split here as you go through and adjust. And we get a reminder here, 25 have not yet been assigned. And so we're going to assign that split to all, but we could choose to be more selective about that as well. Again, a lot of complexity in the options for train available. And then ultimately, we're configuring your model. So we, by default, I believe the platform trains on 20 different learning cycles. So in this case, with custom training, it's auto-selecting a slightly larger number of the training and learning. But in this case, I'm just for speed, I'm going to adjust that back down to 20. And we can add notes about the adjustments we've made to make this searchable later. So we can say we changed the epic here. And then we also have different backbones of the model. So potentially dependent upon your use case, it might be better to leverage either one of these. These are different sort of architectures available openly out in the community that we've optimized for use in the platform. And you can see that there are 14 million hyperparameters as part of that model. We can also do items like rescaling. So dependent upon your image size, in this case, we're actually scaling up. That wouldn't be ideal. You could adjust that to be the actual inherent image size, which actually would save a little bit on the training process. And dependent upon your data, it could be helpful to add augmentations. I typically do not play with this that often unless the data, I just am really lacking in having it available. But it is, if you know specifically that it would help just to really increase the variety of the data that the model is seeing. You could add additional types of augmentations. You can also perform crops on the images themselves. And this can be very helpful to focus in on a singular area that is consistent and reduce the overall number of pixels the model is focusing on learning. But of course, you have to make sure your labels are within that crop zone. So from our perspective here, we focused on the epic. And so I'm going to hit this train button. So we're going to take care of the GPU infrastructure in the back end and scale that up. You can actually have up to 10 different models training in parallel if you wanted to test sort of different iterations of your configuration. So all of those adjustments around data augmentation. And you can view the details as the model is running through this process. So in addition, of course, to the infrastructure to support the model training with the GPUs, we are also taking care of your overall audit trail. So looking at the snapshot of the data that was used within training. This is very helpful for being able to revert or go back to potential previous iterations or use snapshots to create new models in different areas. So just having that audit trail happen auto-magically is really very beneficial. So we see that loss chart. So the goal here through the various learning cycles, so remember we selected for 20, so that's what we see here, is this for error rate to come down. So based on the ground truth and how the model is predicting, you want to see that get lower and closer to the 0 value. And overall, it is doing that. It seems to be kind of consistent. So we probably could have kept at the standard or actually run at less, run less cycles. So you can actually stop that in advance. If you, for example, had selected a very high number of epic cycles, we would likely we do actually stop the training once the model is not improving, though you may not visually see that in the platform. But now we're actually calculating the metrics so that you can come in and really understand your model's performance. And of course, view the sort of distribution and training configuration ultimately that you have set. So it's still working on the metrics, but that's actually pretty rapid for training with a segmentation model. So that actually completed. And so we can click to view the report, or we can access that from our list of models. You can see all the different versions, and we can toggle up and down to see the false positive, negative, what ultimately was misidentified and what is correct. And we see the performance actually dipped a little bit, and that makes sense and tracks just based on how rapidly I was labeling and a little less precise overall in my work that I'm doing. So our goal is always to be as pristine as possible with our labels, that data-centric approach over working with optimizing model parameters will definitely always gain you better performance in the long term. But here we can actually view this on the models page. So this is a comparison view of the different performance. So we can see where it's going up and down, and potentially, you know, this one is higher. So I would want to ultimately favorite that model. I've seen many customers with hundreds of different model iterations, especially in the manufacturing community, where new defects are discovered, or there's drift in just what visually a product may look like. And so they're continually iterating and evolving on the model, and the platform makes it very easy ultimately to do that. Before we dive a little deeper into the model reports and model comparison, I do want to showcase how you can leverage our label assist with the object detection project. So you'll see in this example why bounding boxes potentially could be more problematic from a labeling strategy perspective at the outset. So here, when we click in an image, I see the dark lines as the ground truth label. To cover the whole pipeline with sort of the view and placement of the camera, you're getting a lot of other material in your image. And so that's why segmentation to bounding box would actually likely be a better approach. But just to show the different options, what I'm actually going to do is filter for examples where we haven't labeled yet. And we can see that there's actually predictions happening. And based on the original set of data that I labeled with, it's actually performing pretty well. But as the pipeline has moved, we can see the model is not quite as performant. But you can use the label assist tool. So here we can see there's the predictions again at the bottom, and there's this option for label assist. So once I click this, you can adjust the threshold. In a lot of use cases, this might actually show more or less predictions on the screen. In this case, it's pretty consistent just based on the placement. So what I'm going to do though is accept all of them and then work with adjusting these to sort of move through this process a little more rapidly. And in many cases, the predictions will actually be very accurate and bang on to what you're trying to label here. So again, the goal here is just to accelerate, but you want to be as precise as possible. So this actually is pretty good. I could remove some of the black there, and that label is ultimately saved. Maybe come in a little closer. Very good. So a lot of capabilities around optimizing for labeling are sort of continual evolution of using the platform here for a object detection model. But let's come back to our segmentation example here. And we see again the predictions. We've done an advanced training. So now we really want to dive a little bit deeper into our model. So this latest model, which didn't perform as well, we can see a lot of information when we click on the sort of card smaller view of that model. And we can see what was false positive, the sort of count of that, and get this nice visual confusion matrix across the different ground truth and human labels versus ultimately the predicted values. The model is getting a lot correct. So for the amount of energy I've invested, which is a little against our best practice, it's performing pretty well. We can drill down here to see potentially, we would hope the train set would be a little higher in performance, but it's a good sign actually that the test set is pretty similar in percentage here to what the model learned on. That 5% difference is a pretty good sign that we don't need to change too much in our labeling strategy. But we can also take a look at, if we're not interested in just the intersection over union, we can also see the precision or the recall, which I expected the recall to be quite high on this particular data set. But we can also click in to view the full report, and this will bring you into the model's view where you're also seeing that comparison. But you see both the loss chart here, so what we saw as the model was learning, in addition to the validation chart. So this just gives a good understanding of how the model was testing against itself over the training cycle. Again, we can see the split distribution. And then, of course, more interesting is probably the performance report. So we can change which view ultimately we're seeing, whether it's the test set, train, or dev. In this case, I find it most helpful to review the test set. We can also adjust our confidence threshold here, but we auto select the confidence threshold that optimizes across the data distribution. So you can see across false positive, false negative, that this is kind of the sweet spot here. But based on your use case, you may have more tolerance for less or more false positives. So potentially you may want to adjust that. Typically what I find interesting to review is what is misidentified. So I can drill down ultimately and see that it takes a little bit, especially for segmentation, for the labels to load. But as you hover over, you can see what the ground truth mask was on the left here, and then what the prediction mask was on the right. And of course, this will show that intersection between what was sort of missing in the prediction and what was included. So here it misidentified because I labeled for this example some pixels for close to C plant instead of the pipeline, and the model was predicting ultimately that it was the pipeline itself. So could apply as some adjustments for me in my labeling strategy, but ultimately it doesn't need to be that precise because we'd be outputting this to a bounding box. So, but this is how you would use this model report to identify these areas and potentially click back and view in more detail, and then open that data itself and potentially relabel. So once again, really just focusing on being able to iterate rapidly and adjust your labeling strategy as you go through the labeling and training process. But a lot of information here available. You can sort by the error area. That's quite a hard phrase to say, but super valuable. You can always change your model version names. This can be helpful, especially working with different teams. But of course, we auto-generate the names as well with the date and the number of versions. So what we may also want to do is add our own evaluation set. And so you may recall that I created a tag in the platform when I uploaded a set of images. And so now I can actually filter on that and then select all of these and create my own snapshot, which I've actually already done. So I won't redo that, with which to use this same data set across all of my models. So what I'll actually do now is add that separate evaluation set. So we can see here we did the fast, easy train, no test set of data identified. It was also a smaller set of data. I think it was roughly 20 images. But here we did the training option to customize for test. You can also click through the interface and assign these manually. It's up to you in the platform. But what I'm going to do is actually select and add that ultimately to the table. And it's as simple as pressing the evaluate button to see what this same set of data across all of my models, how ultimately that would perform. So lower, so again, I could go in and do some additional testing. Even lower here. All helpful tools in making decisions about how ultimately I deploy. And that's what I wanted to sort of transition to ultimately next. So we've looked at some inaccurate predictions. We've done the model comparison. We've done an additional separate evaluation set. We can see what our confidence thresholds are here, but we can also deploy. And let's say for our purposes, we just like to deploy the latest version to test in different environments. You can see it's very easy to set up a cloud endpoint. So I could just click new endpoint, but I can also run this on the edge, either with our landing edge platform or through our Docker container approach. In this case, I'm going to download the model. But I can also connect to that in Landing Edge. And you can see any previous and sort of the overall deployments that have been performed with this one particular application and project right here on the deploy page. And if I ever need to download the Landing Edge, the latest version of the software, I can do that directly from here as well, or the container approach, and it'll give you all the commands with your API key in the platform as well. So what I'm going to do now, I've actually already downloaded Landing Edge, and I've just created a new inspection point and just given it a name. So ultimately, now I want to configure it, this inspection. An inspection, in this case, is for pipeline infrastructure. But again, we see use cases across industries where it might be defect identification across a wide array of different types of projects. In this case, there's a lot of opportunity to actually configure how you're going to input images and it run on your machine. So if I had an industrial camera connected, I could set that up to run. But I also could take video, either a live stream or convert previous videos to a stream with a open source VLC player, for example, and be able to run this live on video. I won't do that today, but there is actually, and we'll put this link in the chat. It'll walk you through how to ultimately set that up with the RTSP address with Landing Edge. But here we're going to do a folder watcher, and we're going to select for the folder that we want. And we're working with our images. So I'm going to select this folder. So when new images are placed in this folder, we'll start to see predictions if the configuration is set to running. And I can select to either include my API key and connect to LandingLens. This can be super valuable, especially as you're early in your development process, because you can actually port the images back to LandingLens, and this can be really valuable for iterating. So I'm just going to put this API key in and show you how you would have that option and hit connect. So now you can see where the naming becomes helpful. If you have a lot of projects, and then this one's called new projects, so who knows what that might be. This is helpful here. And now I could load the model from where I've previously downloaded it, or I could download it from LandingLens. And we'll do this model. Takes just a moment to load. And now I can actually save my images, the output result from the model, and select to load those results back to LandingLens. And this is where I was mentioning if you were going to do post-processing, for example, to convert the segmentation mask to bounding boxes, you could enter your C# or Python code directly here. In this case, we won't enter that information, but we're going to save our configuration and hit run now. So there's no images, of course, in the folder. So we're not seeing anything there. But when I take these are images the model has never seen before. I will start to see the model predict here. So end to end, we have now completed the full process here. You can see the color distribution is slightly different. And the model is, of course, predicting other plants. Again, in a real life scenario, we would have labeled all plants and then applied post-processing to only showcase a prediction when they were overlapping here. But now I can actually see the output of that. 1 second. We're going to stop running that here. Of our work today. When I come back to the platform and I look at my different deployments, it probably would take a little while here, but you would see that endpoint with the models here, or the images here available, and you can select whichever images you choose to then add back to the build page. So just at a high level, what we ultimately walked through today was the capabilities around data annotation. We can share these slides because they do have the relevant support documentation that goes over this in even more detail than I have done today. But really, beginning to end, we've done the whole model development cycle in roughly 45 minutes, from data annotation, training, understanding the model and predictions, some troubleshooting, and ultimately have deployed. So super exciting. We'd love to open. I believe there's been quite a few questions in the chat. So now I'll start to answer those where I can.
Great. Let's go ahead and kick that off. And everyone on the webinar today, thank you so much for your questions and keep them coming. First question, Meta just released SAM2, segment anything model. Are we using the same model in the annotation, or is it only SAM as you mentioned?
I'm actually not sure if we've adjusted or optimized with the SAM2, so I can connect back with the team and report. We do continually review and benchmark what is available in the space, and where we can prioritize and incorporate into the platform. We do bring that forward. So it's quite possible that I don't know when SAM2 came out exactly. It's quite possible that that's already been included. But yes.
Next question. Is augmentation different from cropping in practice?
Yes. So the augmentations are going to work to adjust the image in some way to provide additional data in the model training process, whereas the crop itself is really focusing the area of the image and doing some pre-processing before it's actually submitted for training to the model.
Next question. Is the model architecture open source? If yes, could you please provide the paper link to the architecture?
So in the platform for each project type, we showcase what backbones that are based on open source architecture with the naming convention. So you can actually search like the seg former or fast VIT. Each project type, so for classification and object detection, those would be different. That would be my best suggestion, to try and find some literature. We do additional optimizations and secret sauce on top of what is open source available. And we do adjust those over time. The models themselves will always be, if you've developed in the platform, you'll be able to run inference on it. But it may be that those backbones for the models change over time, just based on what becomes available, what we see and perform in our own testing. So that's another benefit of working with a platform like LandingLens, is that you can leave some of that architecture design to us.
Excellent. How is your platform picking the appropriate model algorithm to use?
So based on what model training you select, if you do the one-click train, that will select the model based on our own internal benchmarking for each project type that optimizes accuracy for speed and throughput. So being able to run the inferences very rapidly for each project type. So we've done that selection in advance, and that's the benefit of the one-click train option. And again, you do, for each project type, you can select, and that's why it's, iterative and fast. You could try the different backbone types and see if it's eking out performance either from an accuracy or throughput perspective. The hyperparameters are listed as well. So just a higher number might mean that that model would be slower, but more accurate. So it's up to you to sort of make that decision if you're doing the custom training itself. But we take care of that for you for the one-click train.
Next question. The models are pre-built and provided by Landing AI, or can we add third-party model or make changes, add or remove layers of neuron networks?
So for what is provided as part of LandingLens, those are the models that are built on from a transformer-based architecture, your data plus ultimately the backbone. We do not allow for a bring your own model to the platform itself. But what we do offer, and please, I would encourage all to go to our Discord or developer community. We have launched Vision Agent, which ultimately the goal is to allow you to connect many different models, whether you might be working with sort of text prompts and analyzing image or video, etc., together, so that you can create sort of a complex system and approach with multiple models. Potentially, I don't believe you can port your own model just yet, but some open source capabilities are there. So check out the Vision Agent.
Excellent. Can we randomly reshuffle the images for trained test splits?
So if you hit the one-click train option, we will randomize the potential images used in each train test split. We tried to actually keep that consistent though, but it's worth testing some variation and to see. But you can also sort the images themselves randomly and then select those items for your train dev and test splits. So there's opportunity there to sort by random and then apply those images based on tagging or a lot of other filters in the platform to create the train test split if you don't want to continue to hit the sort of one-click train button.
Excellent. Next question. Can I choose between different custom models, such as one specialized in counting and another in segmentation? For example, if I need to not only count the number of people in a place, but also estimate their weight, is that possible?
So that would definitely be a multi-model approach. Currently, the platform is focused on a singular model. So with Landing Edge, you can actually configure multiple models with some code that's actually on our support center. For your example use case, though, what actually you would want to do is take the object detection bounding box output and apply post-processing logic to count the number of individuals. And there's probably also post-processing logic that could be applied based on, and this would also depend on how your camera is set up to help with calculation of weight just based on size within the image. But this is where exploring sort of data that's outside of vision and other sensors might be valuable to help estimate weight. So for that question, I'd actually encourage you to set up a no-cost consulting with us, and we can help understand just a little bit more about your use case and application and guide a little more concretely about what might be the best approach.
Excellent. We have time for one more question. And as Erica mentioned, please take advantage of our no-cost consulting opportunity. There's a QR code. Just schedule some time. When we send out the recording tomorrow, there'll also be a link to schedule an opportunity to speak with one of our visual AI specialists. So we highly encourage you to take advantage of that because we'd love to learn about your use case and see what we can do to help you. Our last question will be, how does it work from ML ops, machine learning ops, CI/CD pipeline perspective? Can this workflow be integrated in a typical ML ops framework, maybe with Jenkins or alternate CI/CD pipelines? Does that make sense?
Yes, is the short answer to your question. Many of our customers are working with their own ML pipelines that are quite sophisticated. And essentially, all of the features and functionality you saw today, many of that's available through our training API. So they're able to incorporate that programmatically. But there are also components like the snapshots for the models themselves that are a part of that pipeline that then they have an audit trail to be able to view that. So, they can store that. What I've seen typically is just in perpetuity but just based on their own data or CIDC requirements.
Excellent. We can squeeze in one more question. How does the data set size and labeling quality differ between the LandingLens implementation versus a large vision model?
So from our perspective of an LVM, which is domain specific and has this understanding of features that may not be available in public data, that would be the main distinction between what's available in LandingLens and then what is part of our LVM capabilities with certain customers. And you'll actually see some domain specific ones come to fruition that you can test today. We've just launched an LVM for histology. You can actually access that at histology.landing.ai to perform image search on very custom special data. And the LVM really helps accelerate and make that more precise. Sure, you can understand that there's not a lot of public available data around sort of understanding disease and tissue. So it's super interesting and encourage everyone to check that out.
Excellent. To our audience, thank you for participating in today's hands-on lab. Thank you for your great questions. I know we didn't get to a few of them. So when we do follow up tomorrow, we'll definitely have some working answers for you. And we look forward to speaking with you. If you can go ahead and schedule some time with us. Erica, as always, thank you for a great presentation. Grace, thank you for your support. Everyone, please sign up for LandingLens if you haven't already. Join our community. Follow us on LinkedIn. And also sign up for our newsletter. We have a lot of different platforms to communicate. We love to hear about you. We're here to support you in your visual AI use cases. Have a great day. Thank you for joining us.